Hello, bachon. Welcome to the class. Today, we are going to get a grip on a super simple but super important topic in probability: independent events. Trust me, by the end of this, the whole concept is going to be crystal clear in your head. So ready? Let's get started.
Okay, just imagine this for a second. You're on your phone scrolling through YouTube Shorts. You swipe up, up, up. You just saw a dance video. Now, think about it. Does watching that dance video mean the next video is definitely going to be a gaming video? Of course not, right? The two events aren't really connected. The YouTube algorithm might show you another dance reel, or some comedy clip, or maybe a cool science experiment. The first video doesn't control the next one. Well, that right there, that's the basic idea of being independent.
And this very simple idea that one thing doesn't affect the other is the absolute heart of what we're going to understand today. So let's take this daily life example and connect it to some actual math.
Right, now for the official textbook definition. I know it sounds a little formal, but it's saying exactly what we just talked about with the YouTube Shorts example. Two events are independent if one event happening does not change the probability, the chance, of the other one happening. That's really it. Simple, isn't it?
Okay, so that's the idea. But in maths, how do we prove it? How can we be sure without just guessing? Well, there is one very simple, very powerful test. I like to call it the golden rule for independence. If you use this rule, you will never, ever get it wrong. And here it is. This is the golden rule. It says that the probability of event E and event F both happening is simply the probability of E multiplied by the probability of F. If you do the calculation and the left side of this equation equals the right side, then butcho, you can be 100% sure the events are independent. This formula is the only check you'll ever need.
Okay, now, I need your full attention here because this is the spot where most students get confused. A lot of people think that independent and mutually exclusive mean the same thing. Let me be very clear. They do not. But don't you worry, the difference is actually really easy to understand once you see it. And hey, don't just take my word for it. Look, even your NCERT textbook knows this is a confusing point. It says so right there on page 418. So let's take a minute and clear up this confusion for good. Just look at this slide carefully. For independent events, the main thing is that they can happen together. Their intersection, the overlap, is not zero. But for mutually exclusive events, they cannot happen at the same time. No way. Think about flipping a coin. You can get heads or you can get tails, but you can never get both at once. So the chance of both happening, their intersection, is zero. See? They're very, very different concepts. Enough theory. The best way to learn maths is by actually doing it, right? So let's take a classic problem. This one is straight from your NCERT book. It's example 10. We're going to see just how easy it is to use our golden rule.
Okay, so here is the question. We throw a single standard die. Event E is when the number that comes up is a multiple of 3, and event F is when the number is even. The question is simple. Are these two events, E and F, independent? Let's find out together, step by step. All right, let's break this down. First, step 1. The total possible outcomes, our sample space S, is 1, 2, 3, 4, 5, 6. Now for event E, a multiple of 3, we have 3, 6. For event F, an even number, we get 2, 4, 6. So what's common between them? What's the intersection? Just the number 6, right? So E intersection F is 6. Now for step 2, let's find the probabilities. P of E is 2 outcomes out of 6, which is 1/3. P of F is 3 outcomes out of 6, which simplifies to 1/2. And P of E intersection F is just 1 outcome out of 6, so it's 1/6. Good. Now for step 3, let's use our golden rule. We need to multiply P of E by P of F. So that's 1/3 times 1/2, which gives us 1/6. And now for the final check in step 4, we compare. Is P of E intersection F equal to P of E times P of F?
Yes, look at that. It absolutely is. We have 1/6 on the left, and we got 1/6 on the right. Because the two sides are perfectly equal, we have officially proven that events E and F are independent. See? It's really that simple. You just have to follow the formula.
Okay, now that you've got the basics, are you ready for something a little more advanced but really cool? This is a logical proof, also from your book, example 13. Understanding this trick will help you see how independence works on a much deeper level.
So, here is our mission. We're told that E and F are independent. That's a fact. Now we have to prove that E and not F are also independent. Remember, not F, which we write as F prime or F complement, just means the event F does not happen. So does F not happening have any effect on E? Let's prove it. Before we do the algebra, just look at this Venn diagram. It makes everything so much easier to see. The entire circle E is made up of two distinct parts, isn't it? There's the part that overlaps with F, that's E intersection F. And then there's the part that is only in E and not in F, which is E intersection not F. So it's pretty clear that the total probability of E is just the sum of these two parts. Keep this picture in your mind, it's going to make the proof a piece of cake.
Okay, let's walk through this proof step by step. In step 1, we just rearranged the idea from our Venn diagram to get the formula for P of E intersection F prime. Simple enough? Now for step 2. This is the key move. We already know that E and F are independent, so we can replace P of E intersection F with our golden rule, P of E times P of F. Now for step 3, it's just simple algebra. We can see P of E is a common factor, so we take it out. This leaves us with P of E multiplied by 1 minus P of F. And now the final step. What is 1 minus P of F? That's just the probability of not F, which is P of F prime. And there we have it. We have proven that P of E intersection F prime is equal to P of E times P of F prime. The golden rule works, which means E and F prime are also independent.
All right, that was some solid work there, but you did great. Let's do a super quick recap of the most important points from today, the things you absolutely must remember for your exams. First, independent just means one event doesn't affect the chances of the other. Second, the golden rule is your best friend. P of E intersection F must equal P of E times P of F. Third, and this is super important, independent and mutually exclusive are not the same thing. And finally, if E and F are independent, then they're not versions. Their complements are also independent of each other.
So now, I have a small task for you. Think about your own day-to-day life. Can you think of two events that are truly independent? Maybe the probability that you win a round in your favorite game and the probability that your friend posts an Instagram story? Think about it. You'll start seeing this concept everywhere. Keep practicing, Bacho, and you will become a master at this. All the best.